This is Shane Picard with a geometry lesson on the sine and cosine ratios. In prior lessons, we talked about the tangent ratio. So today we need to talk about two more ratios that we find inside right triangles. How do we use the sine and cosine ratios in triangles, and how does that use differ from the use of the tangent ratio? The tangent ratio, you may remember, involved the two legs of a right triangle. The sine and cosine ratios, on the other hand, each involve one leg and the hypotenuse. Triangle ABC, and if we're talking about angle A, you can see on the right side, segment BC is the leg opposite angle A. Segment AC is the leg adjacent to angle A. When we talk about the sine ratio, and notice that sine is spelled S-I-N-E, we say that the sine ratio of angle A, or relative to angle A, is equal to opposite over hypotenuse. When we talk about cosine of angle A, we say that it's adjacent over hypotenuse. This expression here on the left is always read sine A or sine of A. It's not sin, it's sine. It's just abbreviated so it fits on the key of a calculator and so that we don't have to write as many letters. Sine A equals opposite over hypotenuse. And of course, cosine A equals adjacent over hypotenuse. So if you're already familiar and comfortable with using the tangent ratios, the only thing to do here really is to remember which ratio deals with which sides. And I'll give you two quick tips to try and remember that. First one is this. When you think about sine, think about the idea of reading signs from far away. And so you can think about the opposite or the far away side. When you think about cosine, think about being together, since that prefix co means together. And of course, the adjacent side is always together with the angle. So that may be one way that will help you. Another way that you may remember these different ratios and their parts is to remember this mnemonic device, which goes like this. Sohcahtoa. Sohcahtoa. It stands for sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. So that may help you remember Sohcahtoa. Most people who study geometry, at least in the United States, have heard of Sohcahtoa and they know what it means. The next thing we need to cover, since we've introduced the three basic right triangle trigonometric functions or ratios, the next thing we need to talk about is how do you know when to use which of the three ratios? The answer to that question is actually quite simple in theory, but it can be a little bit difficult in practice. Suppose we know that this is a 37-degree angle, and this is 8, and I'm trying to find x. I'll ask the question, which trigonometric ratio do I use to find x? The answer is tangent. Why tangent? Because tangent relates opposite and adjacent, and since I know this 37, I need to use these opposite and adjacent. I don't know the hypotenuse, so that's not going to involve sine or cosine. Here we use tangent. What if instead this were 8 and we were trying to solve for x here? We'd use cosine. Why cosine? Because cosine relates the adjacent over the hypotenuse. What if this were 8 and this were the variable x? We're trying to find that variable. Well, we'd use sine. Let's look at one example and actually try to find some of these numbers. Suppose we need to find x here, and we know that this is 42 degrees. How do we solve this problem? The very first thing we need to do is determine which ratio will we use. Well, with respect to this 42-degree angle, we know the adjacent side is 8 and the hypotenuse is the unknown x. So we use cosine since cosine relates adjacent and hypotenuse. So the cosine of 42 is equal to the adjacent, which is 8, over x. Therefore, x is equal to 8 divided by cosine 42. Then we reach for our calculator. I'll take 42 and find the cosine of that. I'll put that in memory. And then I will divide 8 by that number. And we end up with 10.77. Let's look at one more problem real quick. Suppose instead we had a situation where this were 16 and this were our unknown value. This measure is 51 degrees. How would we solve it? Again, the first question we need to ask is which ratio relates the parts here? I've got this angle and I'm dealing with opposite and hypotenuse. So I know that's a sine ratio. The sine of 51 is equal to opposite 16 over hypotenuse x. And so I find that x is equal to 16 over sine 51. We go back to our calculator. So once again, I'll start by finding the sine of 51. And then I will divide 16. After I put that in memory, I'll divide 16 by that number. And we get 20.6. Okay, that's how we use the sine and cosine functions in order to find missing legs or missing hypotenuses. Before we move along, let's take a look at one fact that we should be aware of, and that is the relationship between sine and cosine. The sine of x is equal to the cosine of 90 minus x. Why is that? Well, notice that anytime we're talking about angles in a right triangle, for instance, x degrees, this angle over here is always equal to 90 minus x. Okay, the complements, right? So when we talk about the sine of this angle, we're talking about the ratio between this value over here, we'll call it a, and this value over here, a and c. When we talk about the cosine of this angle, 90 minus x, that is also equal to a over c because it's adjacent over the hypotenuse. So there's always a fixed relationship between the sine of x and the cosine of 90 minus x. Those two values are always the same. A particular relationship is called an identity because it's true for every possible value of x. It does not matter what number we put in here for x. This is always a fixed relationship. How about the inverse of sine and cosine? They work exactly the same as the inverse of tangent. When we're trying to find an unknown angle measure, we use the inverse of the functions. So let's look at an example. Suppose we have this triangle. It's a right triangle. Suppose that this is 6 and this is 11, and we want to know the measure of that angle right there. First question we ask is which function would relate the various parts that we have identified here? Well, we have an angle, and we're dealing with opposite and hypotenuse, so it is the sine function. So we'd write that the sine of x is equal to opposite 6 over hypotenuse 11. And then we simply say that x is equal to the inverse sine of 6 over 11. And we could also write it this way. Inverse sine 6 over 11. Then we go to our calculator, and the best way to do this here is to put the 6 divided by 11 in some parenthetical expression. And then we simply take the inverse sine, push the inverse key, and we'll hit sine, and then we know that x is equal to 33 degrees. So that's how we find the missing angles using sine and cosine. Of course, when we use cosine, we're talking about a situation in which we're dealing with the hypotenuse and this adjacent side down here. I recommend you find some problems to work through on your own, and as always, if you have any questions, go ahead and send me an email.